So I think some of you may have been expecting a different talk, but you're stuck with me. So welcome and thanks for coming. So I'm with Acesio. It's a healthcare startup, and we're looking at environmental data for healthcare. Prior to Acesio, I spent a number of years at Yahoo. I have a Ph.D. in electrical engineering, so I've come more from the tech side. But I think healthcare is sort of the new frontier. It's a really interesting space. And specifically when you look at data, it's really, really fascinating because the environment has a huge impact on our health and how we treat it and how we deal with it. And if you think about it, it's a global problem, right? So this is, according to estimates, more than 12 million people died from living in unhealthy environments in 2012, and about 1 out of 4 deaths are attributed to the environment. So it's really important, and it's amazing how important it is, but the environment really determines our health to a great extent. And if you look at the factors that make us sick, they can be roughly broken up into these categories. So about 50% of it is your own lifestyle. That includes things like income, development, education, social exclusion, gender, employment, working conditions. We spend a lot of time at work, so that's pretty critical. Housing, community belonging, and so on and so forth. About 25%, it's fairly small, right, is the actual healthcare. That includes the access to health, waiting times, healthcare system access. And then your biology is only about 15%. And that's kind of fascinating because now that we're sort of entering this new AI era and everyone's talking about data and AI and machines, it doesn't take long to realize that our bodies are in many ways like machines. And if you're running a marathon, if you train properly, you're more likely to do well than not, and if you eat properly. And that's why medications work and so on and so forth. So biology is one of the factors, around 15%. And then roughly the environment is another 10%. But this is not real in the sense that environment and your life are very strongly correlated, and you can put them in the same bucket. So I would actually argue that it's more like 60%. And now, if you start thinking about the data that has to do with your health, I think it's clear that it can be sort of divided into 2 categories. One is the data in your patient record, or the patient electronic record, and all of the data that's outside of that. And that includes what you see here, right? So in the electronic record, things like diagnosis, reports, so on and so forth. And then everything outside, the socioeconomic factors, whether you smoke or not, what you do on your daily life, your physical environment, your physical activity, your access to healthcare, and so on and so forth. So behaviors, economic factors. So you see what we're getting at, right? A lot of data that's external to healthcare, which can give us insights into your health and help us lead to better health and better care in general. Now, let's shift a little bit to healthcare as a whole and sort of what a doctor does. And this is my biased view, and I'm not a doctor. But if you think about it, doctors undergo very lengthy training, on average maybe 12, 15 years, to become a physician. And what do they do during those years? I mean, they learn a lot of stuff, but a big part of what they do in their when they're interns is to see a lot of cases, right? And to learn from many examples. So if we were to trivialize that, in essence, what they're doing is collecting a lot of data and matching them to mental models, which you could view as machine learning models, right? So when a patient visits a doctor, essentially what happens is the doctor collects some data, by extracting some features, right? Temperature and so on and so forth, whether you smoke or not, how many drinks you have. And that's an interesting one because the number of drinks, depending on the country you're in, might mean different things. If you live in Europe, having a glass of wine per day is considered okay. If you're in the US, they'll look at you and say, you're kind of alcoholic. That goes beyond the threshold. But a doctor is typically collecting data and matching that to a model and then making a prediction, a diagnosis, and an action, right? So at that basic level, it really is like a machine learning algorithm, right? You're just building a model. So the doctor is building this model in his head over many, many years. And then every time he sees a new patient, they're matching and making a diagnosis. Now, clearly, what doctors do goes way beyond that. There's a human element, the communication, which is really critical. But a big chunk of the time that's spent by doctors is dealing with these very trivial cases where maybe 95% of them could be solved by a machine because it's, they're just doing a basic prediction. So that's sort of one view. And I just want to show you this video because I think it's, let me see if I manage to open it. And what I like to show with this one is just basically besides waking people up, I think that we adapt to bad technology on one hand, and on the other hand, a lot of professions are they move slowly, right? And Vinod Khosla, who's one of the most important VCs in Silicon Valley, has made statements about medicine, and he says a lot of the instruments that, and I'm not quoting him exactly, but the gist of his statement is a lot of the instruments that doctors use are the same ones that they've been using for 100 years. It hasn't changed that much. But with this confluence of data and understanding that all of this external data has an impact, we have a huge opportunity to revolutionize and change healthcare. Now, given what I just said, how much data has an actual doctor seen in their lifetime? It's really a very small amount, right? Even if the doctor sees, 50 patients per week, it's really small data compared to the number of patients or citizens in a particular population, right? So if we look at some facts in terms of numbers in healthcare, more than 400,000 preventable hospital deaths per year, about 80,000 deaths due to diagnostic error. 75% of the data is unstructured. It's a huge market. The third leading cause of death in the US alone is medical error. 1 in 10 diagnoses are wrong. There are new diseases emerging. And I can't even pronounce this. It's just a lot of data that's being generated on a daily basis. And that's not even considering data outside of healthcare. So let's take a closer look at what factors affect our health. And for this, we looked at the World Health Organization. So it includes things like social and economic environment, physical environment, person's individual characteristics and behaviors. And more specifically, things like income. The higher income levels you have, the better health you have because you have more access to better food. It's not a secret that people in lower income neighborhoods tend to eat more fast food, which affects their health longer term, right? Your education as well has a lot to do with stress and health in general. The physical environment, including the quality of water, air, your workplace. Again, lower income typically mean less advantageous working conditions, which is the next point. Social support networks, personal behavior, coping skills, and health services. And then there's a bunch of other things like genetics and gender. Now, the World Health Organization ranks these factors based on the ones with the highest impact. So when you see the top one, it's transportation, it'd be like, why is that? Well, it's pretty straightforward because if you live in a city with a bad transportation infrastructure, you're more likely to have an accident and you end up in the hospital with a broken nose or concussion. And so the link between that and health is pretty straightforward. Whereas as you go down, in some cases, it may be harder to create that link. But the reality is all of these have an impact. The way cities are urbanized and planned, energy, waste, housing, et cetera, et cetera. The other thing that's really fascinating when you think about it, and I think we're extremely lucky, and hopefully this won't change anytime soon, that we haven't had a major epidemic, of the types that happened hundreds of years ago or even less, like the London cholera epidemic where, thousands and thousands of people were wiped out. And there have been some of these localized. But if you think about the movement of people and goods throughout the world nowadays, it seems very likely that, at any moment, a major outbreak could happen and it affect very large portions of the population. This is a Facebook picture, however, but it doesn't matter. I think you get the point. If you look at travel trends, it's increased very significantly, and then things like global warming. So within public health, there are several categories, and so this is just a sort of a summary of environmental health. So it just summarizes those things that I said before: people, lifestyle, community, economy, activities. And just to emphasize, it's the man-made, human-made environment and the natural environment that have an impact. And there are opportunities at different levels. One is the hospital, the health system level, and then government agencies for things like diagnosis, late detection, and efficiencies. So if you're a government for a city or a region, for example, and you know that there are higher incidences of asthma in certain regions, then you can take certain actions. Or in terms of transportation, for example, right? So that's sort of the basic idea. So what we're doing is really joining many different kinds of data. A lot of the data, as I said earlier, is not even public data. There are a lot of open data sets that belong to cities and governments and many institutions. And this includes data from the web, from social media, and so on and so forth, and crossing it with patient behavior and clinical data to come up with models that will improve healthcare in general. And I'm not expecting anyone to read all of this, but if you look at it, at a very high level, there's all kinds of information. Credit card purchases, social media data, transportation, social history, diagnosis, and so on and so forth. So the basic idea is extract all this data, model it, find causations and correlations between behavior, the environment, and particular conditions, and again, at different levels: hospital, health system, and government. So just to give you an example of what this might look like, and this may not be the best example, but it's all about building tools that provide actionable insights on different disease. So when you, for example, when somebody visits the doctor, the idea would be that the data that's collected from that individual is aggregated with all the data from all other patients. That includes a lot of the external data that I mentioned earlier. And then based on that, you would have a bunch of factors for that particular individual or for a particular patient population. So you start correlating alcohol consumption, tobacco use, et cetera, on specific conditions. So what are the challenges in realizing this vision that we have? And there's a panel this afternoon in data and healthcare, and I'm assuming they're going to talk about some of this stuff. But healthcare, I think, is really the next frontier that's going to be revolutionized by tech and AI, because it's really, really, really data-driven. There's no question about that. But the problem is, on one hand, a lot of the data is in silos. You have pharmaceutical data, clinical claims cost data, and then patient behavior. And there's a lot of progress in each of these, but interconnecting it is still a fairly major challenge. And so, and it can be summarized, as I said above, data silos, duplication, unidirectional information, and static insights. And I will go to another funny video just to wake you up in case I managed to put you to sleep. And I assume most of you have seen this video, maybe, but I still get a kick out of it because that's one of the other challenges. In most hospitals and hospital systems, IT and tech is a cost center, meaning it's something you need to do. It's not part of the ecosystem in helping things become more efficient. It's not an investment. So that's a challenge. And I think in general, and I'll shift a little bit more to how I see innovation and data science in general. What I think we need to change, not only in healthcare, but in all of the other industries, and in some we've been more successful than others, is to take an approach that I call human-centered computing. And what that entails is thinking about the user at the very center of whatever we're doing, whether it's algorithms, data analysis, designing an interface, or putting something into production in whatever system it is. And then you have sort of three entry points. You have data, design, and hypotheses. And you can start innovating by starting by any of these three, but then you have to iterate between the other two and then come back. So you start by analyzing some data, then you form some hypotheses, You look at the design, which impacts how that data is being collected. Then you look at the data again, and so on and so forth. So every time you do this, you're kind of going in circles, and I view it as a funnel. So the more you do this, the closer you get to the user who's in the center within a particular context. And that's what leads to innovation. So I say that it's a cycle, because you really have to do this in data science. And more specifically, I view it as work at the intersection of user experience, data analysis, and what I call human aspects. Now, you notice I have user experience and human aspects as two separate categories. That's because in the human aspect, you need to look at things like culture, memory, cognitive abilities, and so on and so forth. You can think of any product, from that point of view, right? Whereas user experience is the experience of actually using the product, where it's a medical device or it's a dashboard for doctors of the type that I just explained. And then the data analysis is the more hardcore sort of quantitative work, and then the machine learning is at the intersection. So in terms of big data, I see 5 dimensions in how it can be used. And again, I'm shifting a little bit to more generic data science. Design, so design of, if it's a web-based interface, it impacts design, and you need to understand that to understand the data. The algorithms that you use in presenting the content, again, whether it's a prediction or a diagnosis in healthcare or somewhere or a different area. Insights into behavior. So if you're just analyzing a segment of the population, you can get insights into what they're doing and what those factors are. Sociocultural analysis as well, which is related to the insights. And then what I call personal insights. And so to succeed, and I've done this for many years, using mixing qualitative and quantitative methods. But as data scientists, I think this is something that we need to do, and it's looking at methods such as informal interviews, focus groups, surveys, crowdsourcing, Wizard of Oz, using user evaluations and A/B testing. And a lot of these come from the human-computer interaction community. And you don't hear too much about this in data science. And I think this is something that we need to push for, because the data only takes you to a certain point. And to really understand the data and the users, I think you need to apply many of these techniques. And so I'm a champion of doing that. So the key points, this applies both to the healthcare case and in general. Yes? Okay, I'll say it when I finish, just in case I run out of time. Key points, it's less about the data. We're talking about data, we're at this data conference, but it's not really about the data, it's about behavior and understanding behavior. And whether it's healthcare or finance or gaming or whatever it is, to really get to the bottom of that, I think you need to understand the interaction and the design. They really go hand in hand as key elements. And to do that, you need to segment, experiment, iterate, innovate, do it within a context. So it's an iteration that continues. Data science itself must be strategic. So I talk to a lot of companies, and sometimes I find they don't know what data science is. There's no executive buy-in. I think that's really, really critical for any company to succeed in business from this point forward, because data is becoming so important. So it must be strategic top-down, but it must be exploratory, meaning that the data science teams need to have the space to explore and to do some of that soul-searching with the data. Defining the right metrics is really critical. There's nothing worse than setting up a data science team and not knowing what the metrics are and not figuring those out. And that a lot of that is part of this data science team. A/B testing is when you test a product using 2 different conditions, and you try out, this version of the web page versus that version of the web page. But it's done with all kinds of products. And then a strong human and interdisciplinary focus. And the next frontier, and I've heard a few things today, is what I call small data. So although we're aggregating all the data, like in the healthcare example, at the end of the day, it's the small data of individuals that will really have an impact. And so to close, I'll answer your question about the Wizard of Oz. This was a technique that was developed in the 70s, maybe even earlier, in dialogue systems. So the basic idea is, let's say I want to develop an AI that can have a conversation with you. Back in the 60s, it was very far from possible. Even today, it's not quite there yet. So you would set up a computer. I think you're kicking me out. You would set up a computer and have people come in and tell them, this is a smart machine that can have a conversation with you. And so the person would start talking to the computer, but in reality, there would be a person in the other room having that conversation, and the user wouldn't know that. So it's a way to test hypotheses on things without building them and using humans to do that. So that's the end of my talk. Thank you very much. I know I talked about a lot of stuff. Feel free to talk to me afterwards. Thank you.